In today's class, we're looking at, we're going to be solving some problems here. This problem has to do with volumetric analysis. You know, in volumetric analysis, you can be asked to find, we normally use it to find concentration of substance in solution. And then here we have a question. This question we are going to be solving has to do with, we're going to be finding we're going to show you how to find the atomic mass of unknown substance that's given to us, and also the molar mass, like what we have here. You can see that the molar mass of this cannot be, ascertained because we have what? X there. Because of this X, no one can just say exactly this is, maybe let's say it can be calcium, it can be what? Sodium, it can be potassium or anything at all, but because it's not given there, you cannot really say exact one. So in volumetric analysis, some of these things can be determined. Now we are given a question. They say that 10 grams of S-hydrogen triazole-carbonate dissolved in water are made up to 1 dm cube. 25.0 cm cube of this solution required 24.90 cm cube of 0.1 mole per dm cube hydrochloric acid for neutralization. Calculate the molar mass of the acid salt and the atomic mass of X. So the possible method to get this thing done is the volumetric analysis, because we know that there's a neutralization here, and then we know that acid is there, triazole carbonate is also there. So in that case, something we can do here is to compare the relationship with using what? Volumetric analysis. And before we do this, what we're going to do now is to look at the balanced chemical equation of what really transpired between the acid and the acid salt. So by so doing, we have hydrochloric acid will give us plus water and triazole carbonate gas aqueous. So this is exactly what we have in the balanced chemical equation. From the balanced equation, we notice that the mole ratio is what? 1:1. But now there's another point I want to make clear here. Say that 10 grams in 1 dm cube, that means in 1 dm cube of the solution contain what? 10 grams. That is to say, the solution is a kind of a standard solution in the sense that it has a known gram in what? 1 dm cube. So, but then we don't know the number of moles involved that is there, because we would have done it the other way around if we know the value of this X. But since we don't have the value of S, we can only do with this volumetric analysis calculation. So in this problem, to solve it, we normally use CaVa over CbVb equal to Na over Nb, where the Ca is the concentration of this acid, which is equal to 0.1, and Va is the concentration of the volume of the acid, which is times 24.9. Now we'll go down there. Cb is the one we are looking for, because we need to know the concentration of this inside the solution of the acid salt. Then we know the volume. The volume is what? This is Vb, which is 25, and the mole ratio is what? 1 is to what? 1. So in that case, if we cross multiply this, we will have 25 Cb equal to 0.1 times 24.9. Now Cb will then be 0.1 times 24.9 all over 25. So by so doing, we can point times 24.9 divided by 25. We have 0.0996 moles per dm cube. 0.0996 per dm cube. That is what we have. That means in this 1 dm cube, the mole concentration in moles is what? 0.0996. So now we have the mole concentration of this acid salt. We can also find the molar mass. Remember, to get this molar mass, there's always a relationship that exists. That relationship simply is what? Mass, moles is equal to mass over what? Molar mass. Just always remember this. It's very, very important. Very, very important in what? Chemistry calculation. So we know that the mole concentration here is what? 0.0996 equal to what? Mass. We have the mass, yes, we have the mass to be what? Our mass is what? 10 grams. 10 grams will be up. Molar mass is the one we don't know. I use mm to represent it. So when we cross over, you notice that we have this m molar mass. The molar mass will then be, when we cross over, we have 10 over what? 0.0996. And that's what we are going to get. If you cross over, we have 0.0996 mm equal to what? 10. Then making m the subject of the formula, that will give us what we have here. So let's see exactly. Let's look at what we should have. What we have here will be equal to what? 100. I can say 100 gram per mole. 100 gram per mole, because we are looking at the molar mass, because the unit of molar mass is what? Gram per mole. We can say it's 100 gram per mole. Now going over to the next one, we are going to be solving the atomic mass. The atomic mass of what we are looking for. Since we have the what? The molar mass now, and we know that S is equal to what? 100 gram per mole. And X is unknown. If you add up everything we have here, we will get the what? 100 grams. So, but S, we don't know S. S plus what? Hydrogen is 1. Carbon is what? 12. We add 12 plus 12. S plus 1 plus 12. And then, which other one? Oxygen. We have oxygen to be 3 oxygen there. That means 16 times 3. We have 4 8s. All of them will give us, I think, should be 61. Let me just finish. See, 1. Okay, 61. We have what? 61 in all. 61 what? Plus 61 plus what? X. 61 plus X, because this we don't know. So what it means, what we are going to do now, 61 or S plus 61 is equal to 100. So if it's 100, what we do here is that then x will then be equal to 100 minus 61. 100 minus 61. 100 minus 61 will give us 39. That means S is equal to what? 39, which is the same thing as the what? Atomic mass of this substance we are looking for. So thank you so much for being part of the class. If you are joining for the first time, we encourage you to subscribe and leave any question you have for us in the comment section. Don't forget to like and share. Thank you so much.